All right, so this, let me dismiss all this stuff. Ugh, of course. Now, this is our graph maker, and I'm going to post it up here. It does have Connor's name on it because I sent one to him because we were doing logistic regression. Let me handle the simple things. Let's say you have to run a one-way ANOVA, right? These ones are easy. What you have to do is you change all your green labels to fit with your design. Okay, so this is your IV1 name. Let's say it's, I mean, it would be like condition, cognitive load, control, right? If you had a third condition, we don't, whatever. But you just rename all this stuff to fit your design and rename your DV. Then you put your three means here and your standard errors from Jamovi here. Now, you should know how to get those. If not, that's okay. We'll figure that out. But essentially, you plug in, you change the labels, plug in these 6 numbers, and the graph changes. It should do so automatically. And you can see it did. Make sure you change the data. Sorry. It's late for me, y'all. This one's easy. Another easy one's correlation. So here your predictor is an IV, outcome is a DV. You will copy your data from Jamovi and you will paste it right here. And when you paste it in, okay, there it is. I don't know why this one was elusive. It was hiding on me. When you paste it in, you'll get a pretty nice scatter plot, okay? You want to change your names, your predictor and outcome names, because that'll change what's down here. Your R squared's on the graph. This is just made up data I made to make this work. We have 103 observations. Let me know if you have problems, but this makes a pretty nice scatter plot. You need to use this when you're predicting a relationship as a main effect, right? Hypothesis 1 between 2 continuous variables. Now, t-test is super easy. That does not matter. I will get rid of that. But you can see you have IV1 name, level 1 of the IV, level 2 of the IV. So you change these green names and they will change in the graph. Your standard errors, so your 2 means go here, your 2 standard errors go here, the graph will change. 2 by 2 ANOVA is the same thing. You got to change IV name, IV1 name, IV2 name. You got to name level 1 of IV1, level 2 of IV1, level 1 of IV2, level 2 of IV2. You put your means in here. You put your standard errors in here. Change your DV name. Now, to give you 2 graphs, because I was super nice with this one, right? Like I was super nice with this one, and these are the same data, it just shows it 2 different ways. So change the green things to what they are in your study, change your means, change your standard errors. 3 by 2 ANOVA, it's the same thing. You just have extra conditions. It's the same exact process. I shouldn't have to describe it. I'm not going to. Now, if you find yourself, which I don't think anybody did based on how we talked, if you find yourself looking at something like load and control versus attempted the hard problem, yes or no, you run a 2 by 2 chi-squared analysis, and these are just counts. So these numbers are the number of people in the load condition that said yes, the number of people in the load condition that said no or did not attempt the hard problem, control, and so forth. These aren't the data from the experiment. I just put random data in there. I'll clean up this file a little bit. Now, this is the easy part of the graph maker. I'm going to do the hard parts next.